Okay. Good afternoon, guys. How we doing? Everybody still awake? 3 o'clock Friday? Yep. A couple yawns. My name is Randy Westergren. Today we're going to talk about hacking for good. I do have a little bit of disclosure. I did borrow my fiance's laptop, so if Pinterest pops up during the presentation at some point, it's not my fault. All right. I am a developer in North Wilmington at a fintech company called Marlet Funding. Any developers in the room at all? Yeah? Okay. One. That's kind of the problem, right? I also have a history of sysadmin work prior to my development life, and AppSec is kind of a hobby and passion of mine, so I bring that to work every day and sometimes at home at night. So I want to start off with talking about what hacking is, or what we think of hacking as. And I really love this image. So many great things about it. First off, it's probably what everyone thinks of when they think of a hacker. You've got all the classics in there. The hood, of course, that goes with it. It's very dark. Terminal's open. Notice there's 2 keyboards that this guy's typing on, 2 different computers. And he also has gloves in case, you know, to be careful, right? So, a lot of interesting things about that picture. But if that's what we think of hackers as, it's not extremely uncommon, right? If you do a quick Google image search for hacker, you come across a lot of these images. Even that guy in the 3rd row, that doesn't look like he fits there. But hacking isn't everything bad. Doesn't necessarily mean even accessing computers or digital hardware illegally. In the traditional sense, in the old days, hacking meant you were coming up with a novel solution to an engineering problem in a creative way. So this is a message from the early days of the Linux mailing list. This is Linus Torvalds' message to everyone. And he's kind of just saying, hey guys, this is some new code base I'm working on, a little pet project. This is a program for hackers by a hacker. Now clearly Linus, who later turned this project into Linux, wasn't talking about breaking into software. He was talking about coming up with an interesting project that solved a lot of problems all over the world. And given the success of Linux, I think he met that goal. So what are we talking about, or what do I mean by hacking for good? All right? If you look at this image, I think this is always a good analogy. If you don't know what this guy is doing, as far as motivation, whether he was paid or not, this might not look much different if he was an ethical locksmith or somebody breaking into a house, right? He's even got a black hat on there. We don't see any company logos, although that could be a misleading factor in the process. This guy looks a little bit more innocent. He could even be working on his own house, right? But he's in the process of using legitimate techniques to break into his house or that given room. But they're the same techniques that a bad guy could be using, right, to enter into software that he's not supposed to be accessing, right? Another example of a good guy that kind of looks like a locksmith being paid to do bad things, or typically bad things if you don't know what his motivations are pen testers. Any pen testers in here today? No? Well, if you were, you'd be wearing that shirt. But altogether, these are grouped under a big term called white hat hacking. We've all probably heard this term before. It's a term used to describe anybody that's hacking in an ethical way and trying not to break laws. This guy is a white hat hacker, right? This is a 5-year-old who escalated privileges in his Xbox account by switching to his dad's account and found a vulnerability in Microsoft's Xbox, right? He ended up on the Hall of Fame of Xbox or Microsoft's website, and I think he even got a $50 credit for his Xbox store. So that's what a little bit different than the guy in the black hoodie at the first start of it. So traditionally we have a little bit of a variance here from two extremes and then one guy in the middle, right? Black hats, white hats, and this gray hat in the middle. So what's a gray hat? I think a good example of this is something recent. So MikroTik had routers that were had a 0-day and very high number of them accessible across the internet. Somebody was scanning them with a tool like Shodan or just a mass scan across the internet, identifying these routers, and although illegally accessing them, the motive wasn't bad, right? It was to patch the routers so that nobody could abuse them. This is what we refer to as gray hat hacking. The person who was doing this had good motivations, but they were still breaking the law in the process, right? Today I'm going to focus mostly on white hat end of the spectrum, and we're going to talk about examples of AppSec research that has benefited the community as a whole. So what do I mean about when I say security research? It's essentially hacking for good, right? This falls under the umbrella of white hat, but it may or may not be something that's paid for or rewarded or has some financial motivation in the first place, right? If you do a similar image search for security researcher, results are a little bit different, right? Really all over the place. You got Kim Jong-un there on the first row. We've got just a lot of weird stuff going on there. So, but the reason I present this is because it gives us an idea of how galvanizing the term is outside of our community, right? It doesn't necessarily show that this term, security researcher, is understood outside of our industry. I'll talk a little bit about responsible disclosure. Anyone ever heard of responsible disclosure before? And anybody used it or had to use it? Good. So Walmart has a responsible disclosure policy. Surprising to me as I came across this. Basically, it's a process by which a organization or vendor can publish ways for researchers who come across vulnerabilities in their software properties to be notified, in a process by which they agree to interact with you in a peaceful manner, right? There used to be a lot more consensus on, or I shouldn't say consensus, there is a new consensus around the term. It's that it doesn't work, right? Responsible can mean a lot of different things to a lot of different people. It turns out not everyone agrees on what responsible means. So that term is being kind of discarded in favor of coordinated disclosure, meaning the same thing. On the opposite end of the spectrum, we have what's called full disclosure, which is quite the opposite of coordinated disclosure, working with the vendor and waiting till there is some kind of patch release and agreeing on a timeline to release the details publicly. Full disclosure is on the other end of the spectrum, where a researcher comes across a vulnerability, decides that the best way to get that patched is to drop it publicly to everyone. The argument there being that the more people that know about it, it puts more pressure on the company to fix it quickly, which tends to be a critique of coordinated disclosure. And it lets the users know their risks up front. And this is a picture of a screenshot of the full disclosure mailing list. It used to be a hotbed of full disclosure vulnerabilities being dropped day to day. I think you see a little bit less of this now, just because the industry has come a long way in coordinated disclosure. I'm going to talk a little bit more about that. One way it's come forward is bug bounty programs, right? HackerOne is one such program where companies can also operate their own individual programs, but HackerOne is a centralized program management platform for hosting bug bounty programs. So organizations especially larger organizations, can take the load off and have somebody else manage various aspects of that program. Here's a good example of what you might come across as a reward for working with a bug bounty program. So it looks like the Dutch government operates one. If you happen to find a vulnerability in their platform, you get a little shirt that says, "This is all I got," right? This loves a t-shirt. What isn't security research? I think this line is appropriate to draw, very important. Anybody remember this logo? Yeah, you don't hear much about from Anonymous anymore, but this is kind of a genre of hacking we call hacktivism. The idea behind this is somebody is hacking with an agenda. They have some reason to hack, and sometimes those reasons even come later after they've found a vulnerability in some organization's software. You've also got things like this. I'm not going to read the whole thing, but it's an email sent to a business owner, essentially extorting him and saying, we're going to DDoS your site, or we're going to exploit a vulnerability until you pay us Bitcoin. Right? These things are not legitimate security research. These side on the things on the black hat side of things. Security research or white hat hacking also has a dark past. Many of you probably know about the Computer Fraud and Abuse Act. Been used to prosecute legitimate crimes in computer fraud and abuse. It's also been used to, the language has, in the act itself has been leveraged to prosecute what you might consider arguable offenses, where intent was not considered, or just things that we as researchers might come across very often that have no criminal intent or action behind them, right? You also see stuff like this all the time, or not so much anymore, but more so in the past, where somebody operates a cryptocurrency project, some security researcher finds some very serious flaws in it, and then you have somebody that critiques the critiquer rather than accepting the feedback and the scariness of the vulnerabilities in their software. So in here, you know, this guy's threatening lawyers to come after this person. Same deal with this. This is just a recent email of somebody also operates another cryptocurrency project. He wrote up a blog about how there were various vulnerabilities in the platform, different pieces of the software. He gets a reply back that attacking his character is the fact that they're not real vulnerabilities, that there's no way he could hack anything, and all kinds of names. So this stuff is still happens today, but I think my sense is that it's less and less frequent these days. You also see things like this on occasion, where there's legitimate research being presented at a large con like Black Hat. In this case, it was some RFID research. Some company didn't like that research was being disclosed at Black Hat, and they sent lawyers after this guy who was going to present, and it resulted in him not being able to present that research. All right. So these are a little bit of background on AppSec. I want to talk more about the current state and how things are going in the future. Anybody remember Equifax, one of the largest of exploitations of a vulnerability in a long time? Not just the scale of the breach itself, 140 million plus people, but the type of data that was breached. You know, things that we're not going to be able to change. Names, you could arguably change that, but social security numbers, birthdays particularly, we're not changing that kind of stuff after a breach. It's easy to change your password after a breach, but some of this information sticks with us for our life. This was caused by or leveraged through the use of Apache struts. Anybody heard of struts before? A very large MVC Java framework used by developers to more rapidly put together and prototype a web application without having to worry about all the basics. The problem with these large frameworks is, and especially when they're adopted by so many installs, is you come across very, very serious vulnerabilities like this one. This is a CVE that was responsible for the hack in this case. As you can tell, it's of the highest severity. It was disclosed publicly March 10th, 2017, and Equifax was not able to patch it quick enough because it obviously was the cause of their massive breach. We'll talk a little bit about I won't go into huge amount of detail about the proof of concept, but let's go over it a little bit. This is an example of just a regular vanilla web request, right? You've got normal looking headers there, nothing special about it. But to differentiate that from the actual proof of concept that exploited this vulnerability, as you can tell in the content type header, there's a little bit of variable parsing that goes into there, even all the way down to you can find the payload mixed in there, and it's even checking whether it's cross-platform, right? It also checks whether it's Windows or it's a Linux command prompt that they're going to be hitting, ensuring a lot more success, higher success rate for the person exploiting the vulnerability. So here's kind of a look at the timeline of the attack across the internet, or attempts at attacks exploiting this vulnerability. It is thought that March 10th is when Equifax was actually breached, and there's some discrepancy here. A couple different sources say 14th, 10th. There was some knowledge about the attack as early as the 6th, as the Struts released a fix without any announcement of vulnerability being included at the time, although they reserved the CVE at that time. Another big one of recent news is Drupal. Anybody experienced with Drupal at all? PHP framework, content management system, up there with the likes of WordPress, Joomla. These frameworks operate a significant chunk of the internet. In the top 1 million websites, as you can tell. Drupal doesn't have as large a market share as WordPress, but it's up there. And the vulnerability called Drupal Get-In kind of had the same situation as Equifax, where there was a race to exploit this across the internet by bad guys who wanted to weaponize the vulnerability. So another classic case of remote code execution, unauthenticated. You can see that this was, March 28th this year. Quickly after that, exploitation took right off. A quick look at the actual code responsible for it. So this is a web request to update some form elements on the back end of Drupal. There are some markup languages. There's some inputs that Drupal uses on the back end so that they can build forms dynamically. Here's an example of what a legitimate form would have been built like. You can notice that the hashtag at the start of those keys and those arrays are kind of where the input is used. Here's a look at exploitation of that vulnerability. So there's an exec command there. This is a very benign attempt at exploitation, but it kind of just demonstrates a proof of concept. And then you've got a smaller time span, zoomed in a little bit here, but as you can see, as the vulnerability was released, exploitation took off. It settled down a little bit, probably because some patches were going out, and then it kicked back up again. And these are attempts at exploitation, not necessarily successful. I want to touch on, so those are 2 open source projects. I wanted to touch on other software properties, things that are developed in-house by other by companies themselves, and some research that I've done personally that resulted in similar disclosure paths. So one of the big ones I found was with Verizon. I have Verizon Fios at home. They have a My Fios app, so I downloaded this from the Google Play Store and decided to take a look at it. Here's kind of what we're looking at. I installed the app all the way on the left. I've got my phone. I put a proxy between the requests and responses over the internet. Watch those APIs as they interact with the web servers and database on the back end for Verizon. And that's kind of just a classic man in the middle, but it's a self man in the middle, so I can view the traffic itself. All right. Viewing that traffic, I was able to see a number of legitimate requests that went across the wire. One thing to note here, this was over HTTP, but that was not the source of the vulnerability itself. This is a look at the main widgets for the My Fios app as it loads. And as you can see, the third widget has like a mail preview functionality within the application. The request on the right is actually fetching the contents of the mailbox. So this is a legitimate API used by Verizon to fetch actual Verizon emails and put them into the widget to show the preview on the left, and also the full functionality once you click on that widget. Here's an example response from that. As you can see, one of the last keys in that JSON array or object is the title for the actual widget on the left. It says, you know, important changes to your Verizon account, something like that. But I wanted to cover real quick that if you zoom in, it's hard to see it over here, but if you look at some of the parameters in that case of the URL, you'll see a direct reference to UID equals, you know, my username, rwestergren05. This threw up a red flag to me, just because if you're writing these kind of backend APIs, you know that authentication is passed in through the cookies, or even maybe the user info header down at the bottom. It should be inferred who the user is. They shouldn't need to be provided the username. So the same case with the send email request. You'll notice in the payload at the bottom, there's a reference to a UID of who is sending the email. All cases of this, all uses of this API within this application were identified as insecure direct object references, right? So I put in my friend's email to see if I could get his email inbox with his permission, and it worked perfectly. So I could have plugged in anybody's email address and gotten their emails and sent email on their behalf. Here's a quick proof of concept I put together for Verizon so I could send it to them. The first line is just establishing with valid credentials the username and password of my Verizon account. Now, any valid Verizon account would have worked for this exploit. And then I'm building the same request that I showed you earlier, right? Instead of the UID as mine, whatever the target username I put in, right? Anybody that we want to fetch their emails, we could have done this. And then it just loops through the Python script just loops through the response and prints out the headers and the subject and all that. I sent this to Verizon, and I blogged about it, and blogged about my experience and the technical details of the bug. It did get some press. As you can tell, the journalists mainly focus on the negative, right? The fact that there was a vulnerability in the first place. The fact that anybody could have accessed these emails. While that's scary and true, I like to highlight this part, right? I had a great working relationship with Verizon. I'm not going to read you the whole message that they wrote to me, but the last two lines are fairly, I appreciated them, right? I thought that was a very positive. We appreciate the constructive and collaborative approach you took with us to solve the security challenge, working together for everyone's benefit. Finally, we have arranged for you to receive 1 year of Verizon service, right? So they didn't have to do that, and they didn't have to write a nice email. I felt that was a good example of collaboration across the industry where there previously wasn't any. Verizon didn't exactly have a published responsible disclosure program. They didn't have a bug bounty program, but they still took the feedback, and they didn't take offense at it. They took it seriously. Another example I want to use is ad networks. Everyone hates ad networks, right? Because they make our web pages look like this, right? Hard to even get to the content these days. Another guy ran an example called the $1 Million Web Page. He's selling every pixel to make a piece of history, I guess is his goal. But the ad network world is very interesting. And I still don't fully understand it. I don't know if anybody truly understands it, but the way it works at a high level is you open a browser and you're going to a news site and you don't have an ad blocker on or anything. You're rendering ads. You are the client in the green right now. You're hitting the website, CNN.com or whatever, and it goes, their ad provider goes through a series of steps to bid the available inventory on their website at the moment, right? They take into account all kinds of nasty data that we know about today, but including super cookies, things like that. But as you look, it goes through an exchange, demand services, and different ads that actually want to end up and buy the inventory on the website to land the ads. So I started playing with learning more about the ads and how they work themselves, right? So if you're a publisher on your website, your ad company may ask you to put a snippet of JavaScript on your main website. Okay, this usually encompasses the bidding logic that we saw a couple slides earlier, and facilitates the actual ad rendering on the website. I went through and started playing a little bit with ad network, and started just by inserting a hash at the end. As we know, anything after the hash isn't sent to the server when you make a request, so I thought that was a good place to start, since it wouldn't interfere with anybody's servers. It turns out a lot of these ad networks use the main website as a referrer on the page, and this is passed through all those various networks before they end up rendering an ad on your site. Of course, this is cross-site scripting. I'm going to show you how this happened, but on a New York Post, I'm sure they didn't want arbitrary JavaScript running on their being able to be run on their site. This is kind of where that exploit came from. I don't know if you can see that. It's a lot of code there, but there's a lot of red, and then you see an escape out of that red, and there's a document write that's actually trying to write and render the ad. The string is ended with a single quotation, and then arbitrary script can be run from there. Right? It's a classic lack of sanitization. Same was true of Walmart. This was not Walmart's fault. It was not their problem exactly, but because they depended on ad providers who rendered ads on their behalf, it was their problem, right? I'm executing arbitrary JavaScript on this user's ad experience, and I can do whatever I want on that page now, right? So I can collect cookies, I can see if they happen to be logged in, taking a complete hijack of their account. Just another example of how this happened, very similar, right? Document writes all over the place, very nasty JavaScript. But you can see the main screen and the main payload was escaped by a single quote and then arbitrary JavaScript that could be inserted. So I inserted an alert, but a bad guy could have embedded his own script to randomly run whatever kind of script he wanted on those sites. Discuss was another example where I came across this. They have a native ad, another ad system within Discuss, so you can kind of see like sponsored posts and things like that. Very similar requests here. Again, these server-side scripts or engines that were rendering these ads were not correctly parsing payloads after the hash, which are typically not sent to the server, and then not escaping single quotes in this case. In some cases, double quotes, but in this case, single quotes. So we go back to this screen, and this kind of shows the fragmentation of the ad industry. Now, if you guys came across this situation with random ad providers being unable to trace exactly where a payload came from, you might think that it's kind of like trying to disclose in a tornado, right? You just don't know where the requests are coming from, who rendered it, who's responsible for it, and it's really tough. So what I did is I just wrote a blog post about it. And it was picked up, and I was contacted by a couple of the top ad networks. AppNexus is one of them. Brian O'Kelly contacted me, and we worked together on trying to solve this industry-wide, right? He knew a lot more about the ad industry. I knew about the security issues that were going on across the ad industry. He emailed me directly. We talked about it, and he helped me get this issue solved industry-wide, right? Like I don't know all the contacts in the various ad networks. He was able to push that and get it fixed for me. So another example, I bring this up. This is a blog post he wrote after the situation, and he's mainly just discussing the issue itself and how working together, the ad industry can be improved from a security standpoint. So another example, public sector apps. This is a local example I like to bring up. Newcastle County here started or purchased a subscription to a button called, panic button called Rapid, what is it? Is it Rapid?
Rave.
No, Rave, yeah, right. Rave panic button. Very interesting because this app was resold to many municipalities across the U.S. and not just used by or developed by Newcastle County. Rave was right in front of me. So it kind of works like this. On-site premises, hospitals, schools are able to presumably interact with 911 much faster. They share floor plans, they share phone numbers, personnel, things like that. They securely provide critical site information for responders, is their main mission. So I did the same thing. I downloaded the app. I wasn't the usual user of that app, simply because I'm not a school or a hospital or anything like that. But I did sit in the middle of the traffic and try to proxy it also. As soon as I spun it up, I saw requests like this. This stuck out as a red flag immediately, just because you can see the authorization header. That was global, right? So there was one username and password for the app globally. This was static in the app, and all requests were made this way. So as you can probably guess, if everyone in this room downloaded it and put in their own information, you could mimic these requests and access all those all the information within the entire system, right? Here's an example of some of the data that was returned from the previous request. This is just happened to be a pin reset. The app didn't look particularly heavily used at that point. I think it was still new. But again, I worked with the industry on that, and I contacted them, and I let them know that I didn't write that, but I blogged about it, and I interacted with the company. I told them my concerns. They took it seriously, and I thought it was another good story, right? I also put together the technical description of the problem, blogged about it, and it got some attention that I think was well deserved, right? Even though it's a joke that this happened in the first place, it's good that it was taken seriously and it was remediated. Internet of Things, I like this one. AccessLink is a developer of outdoor lighting systems, right? So think billboards on the highway, and they have lighting systems. These aren't the digital billboards that are actually LED or anything like that. They are static billboards with retrofitted with these outdoor lights, and actually have remote control systems built into them, right? They had an app. I drove by a billboard one night and I had this idea. I wonder how those are controlled, right? Turns out Smart Lake develops a solution just for that. But I didn't have a login or password. I still wanted to poke around. So I decompiled the app itself, right? Looked around, looked for the API requests, and boy did I find them, right? If you can see the get customer list method in that Java there that actually runs in the Android application, you don't see any hint of authentication whatsoever, right? There's just a generic request to make this. And I find this pretty often just because I think what happens is developers don't think that these requests will be seen, right? Simply because they're made by the phone. They're not very public. You have to do a little digging to see them. Sometimes install your own root certificate to proxy the requests. But in general, they're not seen by the everyday user. So I opened up a shell on Android, and I set a breakpoint in the do login process. I attempted to log in, and I saw this request go across the wire, right? Actually, I saw, once I stopped it, I manually ran the get customer list, and all the customers were returned without any authentication whatsoever. So You can see there's a lot of interesting information that could have been abused in this system. This is one, I think this was a demo account, but all the structures that were managed by this account. And so any user could have manually gone through the system and taken ownership of all these structures. Any company's billboard and really turned off all the lights, right? I presume billing information and other things would have been in there. Also on the web server of the main web server for the APIs, directory listing was enabled, and there was all kinds of logs on there. And you can see the logs were open. There were literally username and passwords within the log files on the public web server sitting with directory listing enabled. So once again, I contacted Outdoor Link, and we worked together on it, right? Security stuff happens, and working with these guys instead of berating them on Twitter or something ended up to be a more positive experience, right? I won't go through the entire process, but what ended up happening was the vendor turned off the old API. They were creating a new one anyway, and they phased that out and went with a properly authenticated and authorization framework. So looking forward, the industry, I think, it tends to be improving, right? You're seeing wider acceptance of bug bounty programs all over the place. I showed you a few examples where even those that don't have bug bounty programs or coordinated disclosure processes publicly established, they're still willing to work on security problems, right? Department of Defense is expanding their bug bounty programs. I mean, this is huge stuff, right? Few facts, figures from BugCrowd, one of the larger bug bounty programs. You can see just year over year, rapid increase in adoption and researcher payouts. Again, this is a breakdown by industry. I find this very interesting, just the amount of industries that are outside of technology that are adopting these programs. I mean, healthcare, government, these are areas that we particularly thought that security was not a priority, and maybe it still needs a lot of work, but it's trending well, right? These guys are starting to start bug bounty programs. It's unheard of. Another good example of moving forward is security.txt. This is an RFC still in draft. The goal is to standardize coordinated disclosure programs. So if you don't want to operate a bug bounty program, that's fine. The idea is that all organizations should have a published security contact, right? And this kind of codifies that. As you can see, the main goal here is to define a standard by which organizations will describe the process to interact with independent security researchers. Here's an example of security.txt file, very simple, right? Just a contact. This happens to be, they have a HackerOne profile. But PGP key, anything that would be relevant, and you can go through RFC to find more details about that standard. Still room for improvement. I think that developers need to continue to get better about security. I think it starts with developers, and they need to be concerned about this guy, right? Not the gloves or the two keyboards that he's typing on, but the active attempt at exploiting whatever he builds, right? Because in the end, it's all of us that are responsible, right? Thanks. Any questions? Sure.
Can you discuss a little bit about the differences in your opinion on coordinated versus responsible disclosure?
Well, I think they're the same term. I think that's what I was trying to say. Responsible disclosure is an older term. I think they mean the same thing, in my view. Responsible just being replaced with coordinated means your responsible isn't different than mine, right? We don't have to argue about what responsible means. Some people think if vendor hasn't resolved the vulnerability in 90 days that it's automatically full disclosure. No ifs, ands, right? There may be edge cases where 90 days doesn't exactly make sense, or it's hard to update product. There's a million reasons out there, I think. So.
Do you they might be motivated to patch it quicker if the public is aware of it.
I think that's where the agreement, every situation is different. I've had to get in situations that are a little bit nasty, where I've had to threaten full disclosure. I never really wanted to, but I've had to threaten it a little bit. Each situation is different, I think. I find that uniquely, because I'm a developer, I can argue with developers because I know what it takes to fix an issue. It's a little bit harder if you're not familiar with the back-end engineering that goes into a given vulnerability. But in general, I think that you can't pressure them. You know, either extreme is unacceptable, right? You can't not patch a vulnerability in a year, or you can't expect that a couple business days is enough for the development cycle. So I think each situation is different.
Do you think that each organization that mitigates these vulnerabilities that are found should be the ones to be disclosing the vulnerabilities rather than people outside the organization?
I think, again, I think that's between the researcher and that company.
So you agree that there should be a conversation had beforehand to say who discloses the vulnerability?
If it's patched, I don't think that, again, it depends on what kind of software this is. If it's just like a SaaS solution or something like that, I think once there's been a good conversation about the validness of the patch, I think there's been many instances where I've written a blog about the technical details of the blog or an issue, but not necessarily said, are you okay with me disclosing this issue? I think that's one of the advantages of being independent. You're not exactly looking for their approval all the time, right? You're working with them, but I don't think it's fair to say, don't tell anyone that you did this, because I didn't enter into any agreement with you, to not do so.
Right. Okay. So follow-up question to that: do you think that coordinated disclosure should occur with that organization? So you should at least, if you are going to be disclosing something, you should coordinate and say, hey, I'm going to be releasing it on this date, just FYI, or
up to you and how the process went, right? I think I did. I can't remember exactly, but I think I did mention to Verizon, hey, I'm publishing this. I didn't ask, but I said, I'm writing a blog about it. Not to ridicule you, but more to document the technical details behind it. I will talk about, and I did, like the experience with them, things like that. So,
going to that answer, do you? I know how you were saying that sometimes people publish the flaws online to force the company's hand to fix it.
Full disclosure.
Do you blog about it, the technical documents, after it's all been patched? So.
Yeah, that's what I view as the responsible or coordinated approach. I've never done full disclosure. I understand people that do. I'm not knocking it. Everyone has their reasons. I may not agree all the time. Again, it's a researcher by researcher, vulnerability by vulnerability kind of situation, I think. Is that it? Sure.
You mentioned one of the bug bounty programs and services. I'm curious if you work with them directly as a researcher. Do you have a preference for one over it?
I've used both. I like them both. I think HackerOne is a little bit more incentivizing in that they have some leaderboards, and maybe Bug Crowd is doing this too. But HackerOne has some interesting, like when a company is not just they're not giving away swag, or they're not giving away monetary prizes. They have a unique system that looks like gives points to developers, and they kind of fight each other for rank, and it kind of puts a game around it instead of doing it for a T-shirt or whatever. So.
Thanks.
Sure.
I saw your presentation on the Verizon web app at Delaware OWASP a year or so ago.
Oh, right. Okay.
Yeah, and I'd asked you at the time if you did this in your spare time and how long it took you to find. And I was just flabbergasted at how fast you could find it, yet these kind of apps get out there into production where it seems like if you could find it that fast, why can't the security environment, the proprietor find it?
Yeah.
And then maybe 2 months after your presentation, it hit the newspaper about an app from the police department for the homeowner so that they could record their valuables in the
Oh,
event
yeah,
they get
yep.
burglarized.
I remember that one too, yeah.
That had the same vulnerability, and it's
Yep.
just mind-boggling.
Yeah, security is hard. I think everyone in this room knows that. It's easy to get wrong. Some of the stuff I find, I agree with you, is surprising. It's kind of low-hanging fruit, the first thing you would look at as an adversary. So it is surprising. I think all we can do is work on it and work on developer education. Is that it? Thanks, guys.